Once again, welcome back to the Math Revision Made Meticulous video series. The topic is application on derivatives. At this video, we will see increasing and decreasing functions. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The step-in answers are supported by the ideas used for getting the answer. Let us see what is the idea of increasing and decreasing function. Let us start with the function f of x is equal to x square. You know that it is a upward parabola. Already you have seen it in class 11. Okay, now let us see the graph now. You just see this animation. Now you are seeing that the graph of this, it starts from the left hand side, it goes down, then after reaching the origin it goes up to the origin. From the left hand side it comes down, and then after that it goes up. Therefore, in the left hand side, to the left of the origin, we observe that when we move from left to right along the graph, the height of the graph is continuously decreasing, it is coming down. And when you go to the right hand side, to the right side of the origin, we observe that when we move from left to right along the graph, the height of the graph continuously increases. Well, now let us see one more way of approaching it. For when it is in the left hand side, you are seeing that the point, the values of x and y, here also the values of x and y. You are seeing that the values of x and y in the left hand side when you move from left to right, and the value of x and y when you move from the origin to the right hand side. And this is to be observed. This will give you an idea about increasing function and decreasing function. Goes on increasing. Well, let us observe it now. In the left hand side, the value of x and value of y you are observing. On the right hand side also, you are observing the value of x and y. And for x less than 0, if the x increases, the value of f of x decreases. And if x is greater than 0, when the x increases, the value of f of x decreases. Now you see one more graph. Here, when the x increases, the value of f of x also increases. From 0x to 1, as increases, the value of f of x decreases. When x is greater than 1, x increases, the value of f of x increases. It goes up, comes down, and then goes up. This is a function x cube minus 6 into x square. Okay. 4x cube minus 6x square. It is a graph of the function 4x cube minus 6x square. Well, therefore, we are now seeing that at some value that function is going up, and then at some point it is coming down. But we are now defining increasing and decreasing function. Let I be an interval contained in the domain. F is said to be increasing if x of x1 less than x2 equal f of x1 less than f of x2. That is, when x is decreasing, f of x also should decrease, or if x is increasing, f of x also should increase. Suppose if it is the other way, that is strictly increasing, then it will be strictly less than or equal to will be there. We have already seen. Decreasing the other way, that is if x1 is less than x2 but f of x1 is greater than or equal to f of x2. If x is decreasing, f of x will increase. When x is increasing, f of x will decrease. Therefore, this function will be called decreasing. Strictly means f of x1 is strictly greater than f of x2. Remember, x1 less than x2, then f of x1 also should be less than f of x2 for increasing. x1 less than x2, f of x1 should be greater than f of x2 for decreasing. Well, now let us see the increasing function, decreasing function now, and you are seeing that it is increasing and then it is decreasing. You just read from left to right. And this is a diagram for increasing function. This is a diagram for strictly increasing function. And this is a diagram for decreasing function. It comes down, and it's strictly decreasing, it comes down. Well, this is a function which is neither increasing nor decreasing, because it goes down, comes up, and then again goes down like that. Therefore, this type of functions are called neither increasing nor decreasing. Now, let us see what you have to do for increasing or decreasing at a point. Now, strictly decreasing, increasing in the domain if there exists an open interval I containing x naught such that f of x is increasing or strictly increasing, decreasing or strictly decreasing respectively. Now, let us see how to find the increasing at a point. Take 2 point x1 less than x2 If you are able to prove f of x1 less than or equal to f of x2, it is an increasing. Suppose if you take x1 less than x2, you are getting an answer as f of x1 is greater than x2, then it is strictly increasing. But this is for increasing. F of x1 less than or equal to means increasing. F of x1 less than means strictly increasing. Now you can remember that for decreasing the other way, that is if you take 2 point x1 and x2, if f of x1 is greater than or equal to f of x2, it is decreasing. Suppose if f of x1 less than x2, but you get f of x1 strictly greater than f of x2, it is strictly decreasing. Well, now you take one example. I have taken 2x minus 19. I will first take x1 less than x2. Let me use this inequality. Let me try to get the 2x minus 19. What I have to do? Multiply both sides by 2. Inequality will not change. I subtract 19 from both sides. Inequality will not change. Therefore, f of x1 is less than f of x2. Therefore, it is strictly increasing. For you are seeing this is a straight line which is strictly increasing. Let us take another function 19 minus 2x. As usual, let me take 2 points x1 less than x2. Now I am multiplying both sides by minus 2. All of you know by the property of inequality, inequality will turn. That is minus 2x1 will be greater than minus 2x2. Add 19 to both sides, but f of x1 is greater than f of x2. I started with x1 less than x2, but I am getting f of x1 greater than f of x2, but it is a strictly decreasing. And you are seeing on the right hand side, you are seeing that the whenever your x is going on increasing, the value of x is going on decreasing. Well, now first there are two tests by which we can, now there are one way of doing is you take 2 points, then find the functional value and then check, but derivative will help you to check whether it is a increasing or decreasing function. There are two tests are there. One is called first derivative test. You have to take a function defined on closed interval ab, then f is strictly increasing if f dash of x is greater than 0, and f is strictly decreasing if f dash of x is less than 0. Therefore, this first derivative is highly useful for you to check whether a function is increasing or decreasing. Find the first derivative. If it is greater than 0, then it is increasing. If first derivative is less than 0, it is decreasing. Well, now suppose if x is a constant, then f dash of x is equal to 0, for which you know this idea. If it is a constant function, then first derivative will be 0. Well, now you are seeing one sine curve now. In that sine curve, f of x is, sin x is increasing on 0 to pi by 2, and it is decreasing on pi by 2 to 3 pi by 2. From the figure itself, I am telling that 0 to pi by 2, it is going up, and from pi by 2 to pi, it is coming down. Now, how to check it with the derivative? F dash of x is cos x. Let us see the curve of cos x now. Fantastic. Now, you are seeing that the cos x from 0 to pi by 2. What is the value of cos x now? F dash of cos x is greater than 0. It is above the x axis. For f dash of x is greater than 0 from 0 to pi by 2. From pi by 2 to pi, are you seeing that the curve is below the x axis, therefore it is less than 0. There is a value of y is there is f dash of x, the value that is, it is less than 0. Therefore, sin x is decreasing. Therefore, when the first derivative is positive, it is increasing. When the first derivative is negative, it is decreasing. Well. Now, how to check the increasing decreasing function in the given interval? Find f dash of x. Check the sign of f dash of x. If it is greater than 0, it is increasing. If it is less than 0, it is decreasing. Very easy. Okay. Well, now if it is 0, then you have to write that it is a constant function. Well, now I will take the same equation or function which I did it by taking x1, x2, x1 less than x2 like that. Here, check whether how it is very easy for you to do it with first derivative. I am finding f dash of x, it is 2, greater than 0, automatically it is increasing. Now, when you take the other one, f dash of x is minus 2, less than 0, therefore it is decreasing. You see how it is very easy when you use derivatives. Good. Let us go to questions now. Please remember the steps involved in it. Very simple. Find f dash of x. Check whether it is positive or negative. Well, show that the function is strictly increasing. These type of questions you should be very careful. Whenever they are asking you to prove it is strictly increasing, prove that f dash of x is always positive. If they are asking strictly decreasing, prove that f dash of x is always negative. These types of problem will come in part A or section A or section B. I am finding f of x. I am finding f dash of x now. I am finding f dash of x is 3 when I take it outside. It is x square minus 2x plus 2, which is nothing but x minus 1 the whole square minus 1 plus 2. I am converting it into a perfect square. Now all of you know that x minus 1 the whole square minus 1 plus 2 is nothing but x minus 1 the whole square plus 1. Therefore definitely it will be always greater than 0. Therefore this function is strictly increasing. Find f dash of x, prove that it is greater than 0. Now I am showing you the graph of this function. You are seeing that x cube minus 3x square plus 6x minus 100 is going up, up, up. Therefore it is strictly increasing. Well, now we are going for another problem involving trigonometry, where you have to prove that tan x minus 4x is strictly decreasing. Keep it in mind that in this interval f dash of x should be proved as less than 0. Let us find. I am finding secant square x minus 4, and x is from minus pi by 3 to pi by 3. Therefore secant pi by 3 is always 2. Therefore it always lies between 1 and 2. Therefore I am finding 1 less than secant square x less than 4. I am just squaring both sides. Secant x cannot be negative, therefore it lies between 1 and 2. Therefore 1 less than secant square x less than 4. I am subtracting minus 4. 1 minus 4 is minus 3. 4 minus 4 is 0. I am getting f dash of x is less than 0. Fantastic. Therefore this is strictly decreasing in the interval. In some other interval it may be increasing. Let us see the graph of it. This is the graph. Oh, fantastic. You are seeing the total graph of tan x minus 4x, but in the red color you are seeing, that's the maroon color, you are seeing from minus pi by 3 to pi by 3 it is sloping down. Therefore it is decreasing. Fine. To check intervals in which, now sometime what will happen, in the previous problem you have been given a single interval, simply it is decreasing, simply it is increasing. Now sometime what will happen, they will give you a total interval in which the function may be increasing up to certain point and decreasing up to certain point, again increasing up to certain point. These types of problem will come for section C and section D. You should be careful. Find f dash of x equated to 0 and split the given interval at these points and check f dash of x at this interval, and then f dash of x greater than 0 means f of x is increasing. Why we are solving f dash of x is equal to 0? We are finding the critical point. What is the meaning of critical point? At those points only the function will change its nature. That is, it may change from increasing to decreasing or from decreasing to increasing. Therefore, we are finding critical points. Split the interval and check the sign from based on the f dash of x greater than 0 increasing, f dash of x less than 0 decreasing. Well, now let us take one question now. I am finding f dash of x 6x minus 6. I am equating to 0. Now suppose if the question they have not given anything, it is assumed that it is defined on the total real number. Therefore I am splitting the real number system into two intervals, minus infinity to 1 and 1 to infinity. You consider minus infinity to 1, you take any convenient point and check whether what is f dash of x. I am getting it as minus 6. Therefore it is decreasing, less than 0. Now I consider 1 to infinity. At x is equal to 2, it is 6. Value 6, therefore it is greater than 0, therefore it is increasing. Be careful while you are evaluating the value of f dash of x at a convenient point. No need to evaluate it totally. You are interested only in the sign of f dash of x. Don't calculate it totally. If you are very sure that it is greater than 0, it will come after calculation. Directly put greater than 0 or less than 0 after that. Well, now you are seeing this function. It is decreasing and it is increasing. Just I gave an example, 3x square minus 6x plus 5. It is a upward parabola because it is a polynomial, quadratic polynomial, and from minus infinity to 1 it is coming down, and from 1 to infinity it is going up. Well, let us go to the next question. Find the interval in which 2x cube minus 3x square minus 36x plus 7. It is a cubic polynomial. Differentiate it and you will get 6x square minus 6x minus 36. 6 can be taken outside. I am solving it. When I solve it, I will get x is equal to minus 2 and 3. Always after getting these critical points, arrange them in ascending order so that you can split the interval. I am splitting the interval into 3 disjoint. At minus 2 and at 3 I have to split, where it will from minus infinity to minus 2, minus 2 to 3 and 3 to infinity. What you have to do now? You have to take this f dash of x, and these are the intervals. Take one by after the other. I am taking minus infinity to minus 2. Convenient point is minus 3 for me. Therefore here I am not calculating. 6 into minus 3 plus 2 negative, minus 3 negative. Therefore you are getting positive. Therefore it is increasing. I am showing you the graph also. From minus infinity to minus 2 it is going up. Let us take the other one, minus 2 to 3. Convenient number is 0 for you. Therefore when I put 0 it is 0 plus 2 positive, 0 minus 3 negative. Therefore I am getting less than 0. Now it is decreasing. Now in the graph also it is coming down. And again 3 to infinity you take a convenient point 4. 4 plus 2 positive, 4 minus 3 is also positive. Therefore it is greater than 0. From 3 to infinity it is increasing. Therefore at a nutshell we will put it all together. Increasing from minus infinity to minus 2, decreasing from minus 2 to 3, increasing from 3 to infinity. Now I am showing you the graph in a better way. It is from up to minus 2 it is going up, from minus 2 to 3 it is coming down, and from 3 to infinity it is going up. It is a cubic polynomial. Let us go to another question. Here be careful, these type of questions are very very interesting. The coefficient of the highest power of polynomial is negative. You should be very careful. Well, I am taking it, I am differentiating, taking minus 6 outside, minus 6 into x plus 2 into x plus 1. When I equate it to 0, I am getting minus 2 and minus 1. Therefore, it is defined on R. I am splitting it at minus 2 and minus 1, minus infinity to minus 2, minus 2 to minus 1, and minus 1 to infinity. Well, but you should be very careful. F dash of x you should not. Okay, we have found f dash of x, that is minus 6 into x plus 2 into x plus 1, and we have already found the intervals in which we have to check. Here you should be very careful. F dash of x should not be taken as x plus 2 into x plus 1 alone, because the coefficient of x square in f dash of x is other than 1. If it is other than 1, remember that the formula for writing the in terms of factor is a into x minus alpha into x minus beta. Suppose if the coefficient of the highest coefficient x square, it is positive, if you put or not putting also it is not going to matter. But when the coefficient of x square is negative, you should put it, because this minus 6 is going to play a vital role to decide the sign of f dash of x. Okay, let us see. Let us take the first interval, minus infinity to minus 2. I am taking minus 3. F dash of x is minus 6 into negative into negative. Be careful. Here when you don't take minus 6, you will get negative into negative as positive. Your decision will be wrong. If it is minus 6 negative, negative into negative, therefore you are getting total negative. Therefore it is less than 0. Therefore it is decreasing, and you are seeing the graph that it is coming down. Similarly, go to minus 2 to minus 1, and I am taking minus 1.5, and I am getting minus 6 into positive into negative. Be careful, this is negative into positive into negative. Therefore it is greater than 0. It is increasing. If you don't put that minus 6, you will get as negative as the answer. Be careful. Well, therefore it is increasing. Now I am taking minus 1 to infinity. Therefore this is 0 I am taking. Good. Minus 6 into positive less than 0, it is decreasing. Therefore you are seeing here that from minus infinity to minus 2 it is decreasing, and minus 2 to minus 1 it is increasing, and from minus 1 to infinity it is decreasing. Comes down, goes up, and then comes down. Well, let us go to the question involving trigonometry. These are all very very important in the examination point of view. Whenever they give trigonometry, they will mention the range. If they give you a problem of increasing the function of polynomial, they may not give you. There you have to take minus infinity to infinity. But for problem involving trigonometry, as they are all periodic functions, they will give you from 0 to pi, 0 to 2 pi, minus pi to pi, like that. Okay, be careful. Well, very quick, we will take f dash of x. I am equating it to 0. I am getting the critical point as minus 1. But when tan x is minus 1, it is minus tan pi by 4. Therefore, it is tan of pi minus pi by 4. Be careful, because minus tan pi by 4 should be written as tan of pi minus pi by 4, which is nothing but tan of 3 pi by 4. Now, whenever you are having tan x is equal to tan 3 pi by 4, the formula is x is equal to n pi plus alpha. Now, n pi plus 3 pi by 4 for n from 0 to all integers. But I want to take only those values which lie in the given interval. For me, it is given that only from 0 to 2 pi. Therefore, I take only 3 pi by 4 and 7 pi by 4. The other values won't come. 3 pi plus 4 pi plus won't come. For I will get only 3 pi by 4 and pi plus 3 pi by 4, which is from 0 to 360. Well, now let me take those values 3 pi by 4 and 7 pi by 4 and It is defined. The point divides it into 3 disjoint intervals. Therefore 0 to 3 pi by 4, 3 pi by 4 to 7 pi by 4, and 7 pi by 4 to 2 pi. We have to check the nature of f dash of x at these intervals. I have taken f dash of x, I have given the intervals. In those intervals, you take a trigonometric value which is convenient to you, which is friendly with you. For example, I will take pi by 2, 0 to 3 pi by 4, 0 to 135, therefore 90 I am taking. For f dash of pi by 2 is cos pi by 2 plus sin pi by 2, you know the value, 0 plus 1 greater than 0, therefore it is increasing. Good. Or take a value friendly. All of you know what the value you have to take. Well, good. Let me take from 3 pi by 4 to 7 pi by 4. I will take pi. Pi will lie between this 180. Therefore, f dash of pi I am finding it is minus 1 plus 0. It is decreasing. Let me take 7 pi by 4 to 2 pi. For this 2 pi, very close to 2 pi, I am having the 330. Of 11 pi by 6 I am taking, that is 330. F dash of 11 pi by 6 is cos 11 pi by 6 plus sin 11 pi by 6, which can be written as 2 pi minus pi by 6. Using all silver teacups idea, which you already studied in class 11, cos 2 pi minus is plus and sin of 2 pi minus will be minus, because sin is negative in the fourth quadrant. Therefore, you will get root 3 by 2 minus 1 by 2. Therefore, it is greater than 0. All of you know root 3 by 2 is 1 point something by 2. Well, therefore, f of x is increasing in the interval 7 pi by 4 to 2 pi. Can we see it in a graph? Interesting. This is the graph of sin x minus cos x. From, you are seeing that from 0 to 3 pi by 4 it is going up. From 3 pi by 4 up to 7 pi by 4 it is coming down. From 7 pi by 4 to 2 pi it is going up. Good. Okay friends, success is dependent on efforts. All the best.